Welcome back. We are now in our second video on circles and proofs. And I do want to point out that while we will be doing some more difficult proof concepts in these 2 pages of the notes, the practice problems that follow that you guys will be doing tomorrow actually focus a little bit more on the stuff from the previous video. So keep that in mind as we continue. Okay? And it's not going to ask you to prove anything. It's more algebraic problems than that. So the first example is asking what is the relationship between a chord, so here, and a tangent. And by tangent we mean, when you have this, highlight's not working there. When you have this line that's tangent to the circle, right, we're kind of asking ourselves how do those interact with each other, having them on the same diagram. So the question that we're going to answer is what is the relationship between A, and by A we mean this little angle A up here. It's kind of hard to see, but it does have like a little bubble. So what's the relationship between angle A and arc measure B? And notice that arc measure B is kind of formed by angle A. So keep that in mind. This one's a little bit different because it opens directly to B, whereas what we saw in the previous video is more like this, where we had those intercepted arcs. So let's first kind of start in a structured way. We're going to look at all these different variables. And we're going to think about, is there a way to define what y is equal to, or what a is equal to, what x is equal to. Keep in mind that as we go through these, different parts are going to be angles, right? And different parts are going to be arcs. So keeping in mind what we're looking at is really going to be crucial. So y is this arc up here, and they don't really give us any kind of a measurement for degrees or anything. I do know how y interacts with b though. If you notice, it is connected to that diameter. So I could conclude, I'm going to put it kind of over here, that b plus y is equal to 180 degrees. That's the measure of those arcs put together would be half of a circle. So if you want to define what y is equal to, you could say y is equal to, if I kind of isolate y, 180 minus b. Okay, so now I have y in terms of b. So it's kind of like, we're trying to decrease the variables we have. Now, can I define what a is in any way? So a is a certain measure. Now, if you do notice, I'm going to kind of erase some highlights that I've done already. If you do notice that there is that right angle here, that means that if I look at a and x, those two measures are actually going to add up to 90. So we know that a plus x is equal to 90 degrees, which means that a is 90 take away x, if we do the same kind of thing as we just did for y. Okay, and I do know some stuff from that previous video lesson about what x and y's relationship is, right? Here's angle x, and it goes to arc that has y, right? So we could say that because of the inscribed angle, 2x is equal to y, or x is equal to y divided by 2 if I do some solving there. Okay, so far that's where we are. Now, what's useful about this is I want to know how A and B relate to each other, and the idea that we're going to do is A, according to the definitions we have at the top, relates to X, and X, if we look back at the top, can relate to Y, and Y can relate to B. So we've kind of figured out a path to get from A to B. Now, I did structure this for you guys. Like, I asked you to find these things. So if you were unaware of these relationships or didn't know where to start, this problem could seem pretty daunting. So generally, the strategy I do anytime I'm forced with a problem like this is I generally look at all the variables and I try and write statements that are true, right? So we would probably arrive at something of this nature anyway, even if we were just like playing around with the information, seeing what we could find. And then once you've got those statements, you want to look for a path like I've outlined down here. Okay, so this is a little bit more, me walking you guys through it. But I do want to point out that that's strategy if you do a problem like this that kind of seems a little over daunting. So let's do that. We know that A is equal to 90 minus x, but x, we can replace that with y over 2, right? Because x and y over 2 are synonymous. And then I can say, okay, that's 90 minus y is 180 minus b over 2. And that's a little bit icky. So let's simplify that. We have that a is equal to 90 minus 180 minus b over 2. So that's what we have so far, and I'll make the a look more like an 8 out of 9. And then from here, I really want to get rid of that dividing by 2. So I'm going to multiply both sides of this equation by 2. So we're going to have 2a is equal to, notice this 2 is going to have to distribute. It's equal to 180 minus, and then if I have 180 over 2 being multiplied by a 2, the 2's are going to be canceling. So it's going to be minus 180. And then from there, you want to keep in mind that that subtraction sign applies to everything. So maybe what I'll do is I'll put this stuff in parentheses. And then I'm going to have b over 2 times 2, so it's going to be just minus b. You could also view it as like 180 minus b over 2 times 2. That just cancels out. Either way. Or you can look at it individually. And then from here I've got 2a equals 180. Distribute your negative sign. That's the really big thing because you're subtracting that whole fraction, so you want to be careful with your signs. So minus 180 plus b. So then if you cancel that out, you get 2 times a is equal to b, which is the same thing as saying a is equal to a half of b. B is double a. So if you look at the picture, what they're saying is that whatever a's angle measure is, it's going to be half of whatever b is. B is taking a and doubling it to get that angle measure. And that, seems logical, right? What we've actually just discovered is that the inscribed angle idea that we saw, remember when we did this, we said if this is 30, this is 60. We've actually just shown that the same thing holds true for the case where one of the sides of the angle is, gone, where you just have that one line extended based on where it is in the circle to create the arc. So we've seen that that concept holds true, which is really interesting. Example 2 is about secants. And the question says, what is the relationship between angle measure A, so this angle here, and arc B and arc C? So arc B, so I wanted a different color for that. I'm going to make it green. Arc B and arc C. So notice that our angle measure A creates both of those arcs. So the question is to think about, how do they relate to each other? If you look at the diagram below, it's actually the same picture just with some extra, or actually one extra line drawn in to make a triangle. Oftentimes in geometry problems, you'll find that doing some extra lines and trying to get a triangle will help you, especially when there are angle measures involved and you're trying to solve for something. So with this picture, we can use some of the triangle ideas to help us out. So let's try and use X and Y to help us figure out some more stuff involving A and B and C. So let's see, I know that the sum of the angles of a triangle is 180. So I know that A plus Y plus the third one equals 180, right? But it's also true that that third angle, I'm just using a box for that top angle up here. The third angle plus x is also equal to 180, and that's due to the angles being supplementary, right? They're making a straight line together. And these two are the same thing, right? And that means that a plus y has to be exactly the same amount of degrees as x, because those angle measurements combined with the shared angle add to 180. So we now know that there's a relationship between a and x and y. if I was to try and rearrange, I could solve for what A is equal to in terms of x and y if I wanted to. Now here's the question, can we relate x and y to C and B? I'm going to erase this. So here's x. And notice you've got that inscribed angle. So 2x is equal C, or x is equal to C over 2. If I was to do a similar step with my y and my b, I would have another inscribed angle. So 2y is equal to b, or y equals b over 2. What I'm now going to do is I'm now going to substitute those in. So I've got a plus b over 2 equals c over 2. If I want to solve for a, that would give me that a is equal to c over 2, take away b over 2. From here you want to combine those fractions, right? So a is equal to c minus b over 2. So that's the relationship here. So if we think about what this means in terms of everything, let's try and think back. So A, that angle measure, is angle C, take away angle B, and then cut in half. And the cutting in half thing, it kind of makes sense because this is almost like an inscribed angle, but it's been adjusted in some way. So it's kind of like instead of just taking the inscribed angle and cutting it in half, you have to subtract the two angles that are involved in A, right? Like B and C contribute to A in some way. They're all connected. So this is kind of an interesting discovery that we've just made. Like I said, you don't have to worry about memorizing this. This is more, we're just exploring these ideas and like working with algebraically proving things that are true. And just a little aside, the same holds true with a secant and a tangent line as seen below. So before we just had two secants, and by secants I mean that this line went through the circle in 2 points, and this line went through the circle in 2 points. This picture below is the same idea, but one of them being a tangent, which is this guy here because it's a line that touches at 1 point. And the same just holds true. I didn't see the need to show you guys why. These are just some proofs that the Competition Math for Middle School book focuses on. And then the last one that we're going to look at is intersecting chords. And this one I would say is pretty useful. This one is more applicable because I have seen more of these kind of problems come up. These kind of problems will be useful in geometry in high school as well as ready for your standardized test. Now, in this picture, we've got the question of how does this angle relate to this arc, and that's what we're going to be exploring. Now notice that the picture already has that this angle here is b over 2. That's because you've got that vertical angle there. The smaller angle doubles to make b. Same is true for a. And now what I want to look at is a quick vocab word, vertical angles. They're talking about these angles here. That's a geometry term. It's when you have a pair of intersecting lines. Angles across from each other are called vertical angles, and they're equal to. So I just wanted to point that out real quick. So the question is, can we make any conclusions about how A, B, and C relate to each other? Using triangle sum, we could say this. Plus, I'm going to call the top angle box equals 180. You also know that angle C plus the box is equal to 180 because those two angles are supplementary. They make a 180-degree line. Similar to the last problem, these are the same. So you may conclude that this is true. If you combine the fractions, C equals A plus B divided by 2. Okay, so really similar to the last problem in structure, but we now have a way to find C is averaging A and B. So that is it for this problem set. The next video we're going to be moving to is doing area, and that's going to be on page 208. I'll see you guys there in the next video.